Hello, and welcome to the Gallery of Graph. And now, here's your host, Will.
Okay, guys, and welcome to today's video. Today we're looking at the Truncus, and this does bring up the eternal age-old question, just like, is it octopuses or octopi? The real question is it Truncus or Trunci? It's, well, of course, plural of Truncus, right? So I am of the opinion that it is Trunci, but let me know what you think and fight me in the comments, I guess. Anyway, so we've got the general form of our Truncus here, which is going to be y equals a over x minus h squared plus k. Okay? And for the a to begin with, well, we all know that dilation factor starts with a, don't we? So
Bazinga!
that's going to be our first little transformation thingy bob there. So dilation factor. And then we also have H, which actually stands for
Put it in H!
horizontal translation there. And then finally we have K. Okay? And K is going to be our vertical translation. Cool. So we've got a squared graph, and just to understand the graph a little bit, well, of course, we have a double up sort of system here. And just like in a quadratic, a negative x value will give a positive y value because it's squared. Negative times a negative is a positive. Okay. And so what does that mean? Well, in terms of x equals 1, we get 1 squared. And then if we were to go to x equals 2, you're going to get 1 over 2 squared, which is 4. So you get a quarter, which is obviously going to be smaller. And so as x increases, y asymptotes out to the x-axis there. The other way, of course, is when x gets smaller, y gets infinitely bigger, but will never reach 0, of course, because dividing by 0 is undefined. And so that is our base Truncus. The next thing we've got to look at is going to be when we change a, the dilation factor. And so a is the numerator of the Truncus there. And when you make the number bigger, well, you're now dividing a bigger number by the same x value in the case of our 1 over x squared versus 2 over x squared. And so what does this do? It means that the graph dilates away from the y-axis. We get bigger y values for the same x. So instead of y x equals 2, y equals 0.25 or a quarter, we now get x equals 2, y equals a half, because you're now dividing 2 divided by 4, which gives you a half. And so that, of course, increases. Say we put in, I don't know, let's put in 69 there.
Nice.
You can see that obviously really amplifies the effect of increasing the dilation factor. Now, when it comes to a number that is smaller than 1, what you will normally see is that a jumps down the bottom here. So if you can see my mouse there, we've got a down the bottom because we now have a half x squared, a half times x squared, or 1 over 2x squared. So a can be, well, if we were to put that as a Franken decimal or a Franken fraction, you can see, right, if I get rid of all the other ones, that these, I'll do the red one here, you can see that a half over x squared is the same as 1 over 2x squared, because it's a half times x squared there. And so that is the effect when you have a value that is smaller than 1, or a jumps down the bottom. Other way of saying the same thing. Yeah. So basically, when a is bigger than 1, the graph goes away from the axes, and when it gets smaller than 1, it goes closer to the axis. The next thing we need to look at is going to be when you have a negative a value. And so, to the surprise of no one, if you've been following along with the series, you would understand that when you invert the a value, you invert the dilation factor, you get a inverted graph, and so we get an upside down boy there. Or a sad Truncus, if you will.
Why are you always in such a bad mood?
I have a nail in my anus.
Oh.
So that's what happens when you invert the a value. Okay, and so having done a now, we're going to look at h.
Put it in H!
Moving on to horizontal translation, of course, h. If you have a positive h value, our graph is going to move to the left.
To the left, to the left.
Right, because of the null factor law, and if we were to solve for x, when y equals 0, we would eventually get to x equals negative 1. And so, because a Truncus has a vertical asymptote in it, this means that we also need to understand that the vertical asymptote will move to the left. So you can see here that no matter what y equals, x is going to equal -1. And so that's what happens when you have a positive h value. And of course, if we change this to a negative h value, well, it moves to the right. So that one's pretty normal. And let's say we make this 3. Well, all of a sudden we've got to go up to 3 for that asymptote to make sense there. If we turn this into, say, I don't know, -9 plus 10,
21.
which of course is 21, well, we can see that our graph moves all the way over to the left there to where x equals 21. And so that is how the h value works there. Just moves it left or right. And of course, we have left being positive and right being negative. And so the next thing we're going to look at is now the vertical translation, or k. Okay? And for k, what we have is well, it's a positive value, just like most other graphs. It goes up. Yeah. And because a truncus also has a horizontal asymptote, you then get the horizontal asymptote increasing. And as you can see here, y equals 1 in all regards, regardless of what x equals. And then if we get a negative k value, then, well, the graph shifts down to whatever that number is. So we could make this x plus 69.
Nice.
Nice. And then our y graph our y asymptote would have to do the same thing. Zooming all the way out there, we've got 69 as our vertical translation, and then that means that the graph goes up 69 spots. Nice.
Nice.
Then, let's say we had a negative number here that was different to 1. Let's just make it 2 because I'm lazy. -2. You can then see that the graph moves down here. So we are now at 2, and the graph is now asymptoting at y equals 2. And so that is how the basics work. And so now let's jump into sketching a graph. Noises alert, erpicoo. Noises alert, erpicoo. Noises alert, erpicoo. Erpicoo.
Wait, what was that? Let me play this backwards.
Book a free trial session.
Book a free trial session. House Tutoring is offering a free trial session and 3 free cancellations per term for sickness and family emergencies. Okay, so the first question we have here is going to be the question y equals 1 over 2 bracket x plus 3 bracket squared minus 4. And the first thing we're going to do here is we are going to firstly find the asymptotes, right? And this can be done by looking at the horizontal and vertical translations. And so for the x asymptote, or x asym, as the cool kids write, what we're going to do is we've got a +3 here. And so +3 means that the graph is going to move to the negative direction 3 spaces, which is going to be left. So we have a left 3.
To the left, to the left, to the left.
And so that means that x equals -3 will be the x asymptote there. The y asymptote, well, you can see that the k value is -4, and so y will equal -4 there. And that's how that one's done. And so now that we have the asymptote equations here, what we can do is we can now go ahead and assume that there will be asymptotes because, well, if we're looking at our basic graph, it's been moved left and down, so there's going to be an x-intercept and a y-intercept there, and then, of course, because it's a double up sort of system, we've got another x value there. So that's the basics. So what we're going to have to do first and foremost is find our x-intercept. And what does x-intercept, I should say, because of course we are talking about a double up graph here. So x-intercept, what does y equal at the x-intercept every single time, guys? It's 0, of course. And so 0 is going to be equal to, what's our equation there again? It is 1 over 2 bracket x plus 3, bracket, plus up there, squared minus 4. Okay, and well, the first thing we need to do to get x by itself using our reverse BODMAS skills, guys, if you don't know what I'm talking about, please check out my YouTube channel and maybe you'll see a video there. And what we have is we have this -4 that we need to get rid of. And so what we're going to do is add 4 to both sides of the equation. 0 plus 4, very hard question. I think that might be 4. So now 4 is equal to 1 over 2 bracket x plus 3 all squared. Okay, and then this is where it gets a little bit dicey. So technically this is 1 over 2 times by 1 over x plus 3 squared. And the reason that we can know that is because when you multiply fractions, you do the top by the top and the bottom by the bottom. So 1 times 1 is 1, and then 2 times x plus 3 all squared is going to be 2 bracket x plus 3 all squared. So this is the same. So essentially, we're timesing by a half. That's one way of thinking about it. We could times by a half, or we're just, dividing by 2 here. So either way, same thing. What we're going to do to get rid of this, though, is we are going to times by 2, which is our thing outside the brackets. So times both sides by 2. That is going to give 2 times 4, which is 8, and that's going to be equal to 1 over x plus 3 all squared here. And so every mathematician who knows this, therefore knows that you can just do a good old switcheroo, which means that we now get x plus 3 all squared equals 1 over 8. So yes, we have x plus 3 squared equals an 8th here, and so what we need to do, of course, to get rid of a squared is to triangle it.
Bazinga.
No, I'm kidding. Of course, we square root our squares to get rid of them. And so we get x plus 3, and because we are, of course, big boys and girls now in year 10, we know that there is going to be a plus and minus variant to our square root, which will be the square root of 8. And we know our surds law, of course, guys, right? Right? Surds? So this is going to be the square root of, it's going to be plus or minus the square root of 1 over the square root of 8. From here, what we can do is then say that this is going to be the square root of 1 is 1, and the square root of 8, that is going to be 4 times 2, and of course we need to split it up this way, not 1 times 8, for example, is because 4 is a perfect square, as in it is 1 times 1, 2 times 2, 2, 3 times 3, 4 times 4, 5 times 5. All of those numbers are our perfect squares, and if we can break up a number that isn't a perfect square into its factors that are perfect squares, we can then simplify a surd. So 1 divided by root 4 times 2 is going to be 4. The square root of 4 is 2, so we get 1 over 2 times the square root of 2. And so we then get x plus 3 equals plus or minus 1 over 2 root 2. And then from there, we minus 3 from both sides, leaving us with x equals negative 3 plus minus 1 over 2 root 2. And so these are going to be our x-intercepts, because we, of course, have negative 3 plus 1 over 2 root 2 and negative 3 minus 2 over 2. Moving on to the y-intercept now, we have y-int. What does x equal with the y-intercept every single time, guys? It's 0. Thank you. And so then what we can do is simply go that y is going to be equal to 1 over 2 bracket 0, bracket 0, minus 3 squared minus 4. Okay, and from here, well, it's simply just solving the equation. 0 minus 3 is going to be negative 3, spoiler alert, so 2 bracket negative 3 squared minus 4. Negative 3 squared is, negative times a negative is a positive, and 3 times 3 is 9, so it's going to be 1 over 2 times 9 minus 4. Y is going to be equal to 1, and 2 times 9 is 18 minus 4. And then we now go into the fun stuff of saying, how many 4s, how many 18ths are in 4? Well, that's going to be y equals 1 over 18 minus, and then 18 times 4. Oh, don't know how to do that. Let's do some side maths real quick. Well, 4 times 8, first and foremost here. 4 times 8, that is going to be 32. And then we've got 4 times 10. But what I like to do is I like to put a 0 down first. Then it becomes 4 times 1. Obviously, 4 times 10 is 40. But if we do this for harder numbers, it makes sense. So, standardizing how we do maths is important. 4 times 1 is going to be 4, giving us our 40. And then 2 plus 0 is 2. 3 plus 4 is 7, leaving us with 72 over 18. From there, we're going to get y equals, it would be 1 minus 72, which leaves us with negative 71 over 18. Gotta love that number. It's a nice round number there. So now we have our y-intercept and also our x-intercepts. We can now go ahead and sketch this graph. We also have our asymptotes up here, of course. So, graphing this bad boy, we're going to need negative 4, negative 3. Negative 3, negative 4. And we're also going to need those points there. So, just out of curiosity, what is our negative 3 plus or minus 1 over 2 root 2 going to give us there? Well, we've got negative 3, and we're going to add 1 over root 2, or 2 root 2, so 2 rootus. And that gives us negative 2.6 there. Okay, now, so just coming to the graphing part, well, the first thing we're going to need to do is slap down our axes. Of course, going to be x and y. So, let's go ahead and put down a y-axis here. Color. put down a y-axis here, and then we've also got an x-axis right about here. We'll do our x-axis right about. Pretty good. Awesome. And we've got y and x. Right. Now, we need to put down the asymptotes first. The asymptote we have here for x is -3. So we can go ahead and, well, if you have a rule with you, go ahead and do that. So -3. 1, 2, 3, cool. So yeah, we're going to put our asymptote down there. And that's going to be x equals -3. And then we have the y asymptote. Now, the y asymptote was -4, so we're going to go ahead and put that one down too. Y equals -4, which is going to be 1, 2, 3, 4 down here, like that. Y equals -4. I've just realized that we've got our side maths in the way, so let's get rid of that. Let's just whack that up there somewhere. Okay, cool. And now we can go ahead and graph our Graphing McGraph graph. I will just extend out that x-axis a little bit so that we've got some more room to work with. Now, looking at the values here, well, we should probably have put our probably going to have to go back and put our answers into decimal form so that we know exactly where we're going. So starting off with the y-intercept, I guess, we'll go onto the calculator here, and we have -71 over 18, and that gives us -3.94444444. So let's go ahead. Okay, so we've got 0, -3.9, and then that is all we need along with our asymptotes. And so that, along with our asymptotes, is all we're going to need. Okay, and so now that we have our intercepts and also our asymptotes, and yes, the graph does look slightly different because through the magic of editing, I changed it so that we had more space. So yes, we've got y equals -3.9, and seeing as y equals 4, or -4 is here, 3.9 is going to be just a metric bee's dick above that. And so that is what we've got there. Then the two x-intercepts are -3.35 and -2.6, which are basically a third along away from the x equals -3 asymptote there. So we're going to put one about there, one about there. And so then we can go ahead and graph our beautiful Graphing McGraph graph. So we're going to go and do that. Don't touch the red though. And we're going to go ahead the other one and do. And then the next thing is to, of course, label our intercepts. So we've got 0, -71 over 18. We have -3 plus 1 over 2 root 2, 0. Just rolls off the tongue, doesn't it, guys? And then we also have -3 minus 1 over 2 root 2, 0. And so that is how we draw our truncus there.
But you have recruiting ads on TV. Why do you need subliminal messages?
It's a three-pronged attack. Subliminal, liminal, and superliminal.
Superliminal?
I'll show you. Hey, you!
Got some tutoring!
Yeah, all right.
I'm in.
Well, now that you know, Lisa, I'm afraid I can't let you leave. Oh.
There is one more style of question that I will show you before we call it quits for today.
Hey guys, just going to interrupt the video for a second, but if you are enjoying it, then please consider supporting the channel. Old Willie's maths and memes don't put themselves together, I can tell you that. So if you would want to support my work, then please consider buying me a coffee or donating on PayPal. Additionally, I do have a Patreon where I'm going to be uploading chapter-specific solutions to the problems out of a popular textbook series that rhymes with Lanebridge, if you're in Australia. And so if you want to get that, sign up for the Patreon. And finally, if you would like more bang for your buck, then why not hire The Real Deal by contacting me on Facebook or Instagram or X or YouTube or all of the social medias and organizing a free trial session from Will's Tutoring! Where you can also get 3 free cancellations per term for sickness and family emergencies. Anyway, like and subscribe to the video. That's the end of the plug. Bye!
Okay, and so for this one we have sketch y equals 3 over 2x plus 4 squared. And what we can see for this one is that there is this 2 next to the x, right? And so what we need to do is we need to pull out a common factor of 2 and put it out the front. So, for the next line, you would expect us to write 3 over 2 bracket x plus 2 squared, right?
Wrong!
It'd be 4 there, right? Because 2 squared is 4. And so now that we have it in this format, in this case, let's look at our horizontal translations and vertical translations first to find the asymptotes. So, asymptotes, we have, well, there is no vertical translation here, okay? So instead what we have is just horizontal translation of plus 2 there, which means that we move it to x equals negative 2. And then with that in mind, the only other thing we would need to find would be a y-intercept, because the horizontal asymptote is going to be at 0, and therefore there's not going to be an x-intercept, because the graph will never touch the x-axis. Alright, so we've got our asymptotes. Now let's just do our y-intercept here. So at the y-intercept, what does x equal every single time? It is 0, of course, meaning that we are going to get y equals 3 over 4 bracket 0 plus 2 squared. And so that means we're going to go y equals 3 over 4 bracket 2 squared, meaning we're going to get meaning that we are going to get 3 over 4 times by 4, which is going to be 16. So we get 3/16 just like that. Easy peasy. Or, in coordinate form, that would be 0, 3 over 16 there. Okay, and so now we have everything we need in order to draw our graphy McGraph graph. So let's slap down some axes here. We have our asymptote there at x equals negative 2. So let's go ahead and put that in there. X equals negative 2. Fantastic. And then we're going to draw our truncus so that it just comes up and gives that. Well, it doesn't actually give that horizontal axis to smoochy there. And then, as you can see, that was perfectly drawn. No criticisms will be taken. Thank you. Or if they are, leave them in the comments down below. Yeah. Or the algorithm. We've got 0, 3 over 16. And then, basically, that is going to be it, apart from maybe if you want to write the equation down, which was y equals 3 over... Now, you could either write it like this or the original format, but we're going to go for bracket x plus 4 squared. And that is how the cookie crumbles. Beautiful. And this is also the end of the video, so if you did like it, please do all of the social media things. Give it a like, give it a subscribe, give it a comment. If you've got nothing to say, just say for the algorithm. We're gonna take over the world with maths, yeah? We don't need AI. It's gonna destroy us all and make us all stupid. But anyway, if you do want more maths, you can potentially give me a good old hit up with the Kofi or the PayPal. Links are in the description below. Yeah, really trying to just do it on my own, so any help that you could give would be fantastic. I also run a tutoring business, and if you go to my Facebook, Instagram, Twitter, you can try and get in contact with me that way, and then we can sort something out. It's online tutoring, it's borderless. All we gotta do is figure out a time that works. Everybody gets a free trial session and 3 free cancellations per term for sickness and family emergency. Anyway, this is the end of the video. Bye!